Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today we're going to talk about the primary way the body regulates blood pH, the bicarbonate buffer system. So, what's a buffer? A buffer is a solution that resists change in pH, and this does so when there are small amounts of acid and base added. Buffers are essential for keeping physiological systems stable. The major buffer in the blood is the bicarbonate buffer system, and this is governed by the following reaction. So carbon dioxide and water combine to make carbonic acid. Carbonic acid quickly dissociates into protons and bicarbonate. The formula for carbonic acid is H2CO3 and bicarbonate is HCO3. This reaction of carbon dioxide to carbonic acid is catalyzed by carbonic anhydrase, and carbonic anhydrase is found in red blood cells. It is very important that you note that this reaction is actually completely reversible. So yes, it does dissociate into bicarbonate and protons, but then if you have too many protons, which is low pH, or too much bicarbonate, then it can go back to carbon dioxide, and we'll talk about this in a little bit. So carbon dioxide transport, 73% of carbon dioxide is transported by this conversion of carbon dioxide into carbonic acid. 20% of carbon dioxide is transported by being stuck to hemoglobin. Now it doesn't bind to the oxygen binding sites, but it binds to the other sites in the protein. The final 7% of carbon dioxide is dissolved in the blood. Carbon dioxide is much more water-soluble than oxygen is, as almost no oxygen can be dissolved in the blood. A key point is that carbon dioxide is treated like an acid because it generates protons when dissolved in the blood. Now your normal arterial blood pH is 7.35 to 7.45. The body is very sensitive to pH changes, as even small deviations can impair enzyme function and oxygen delivery. So how would you estimate blood pH? Well, you could do so using the Henderson-Hasselbalch equation. This is pH is equal to pKa plus the log of bicarbonate ions divided by the concentration of carbon dioxide ions. Now, how do we get all this information? Well, the pKa of the carbonic acid system is roughly 6.1. The concentration of bicarbonate ions is regulated by the kidneys, and the concentration of carbon dioxide is regulated by the lungs. This shows how the lungs and kidneys work together to maintain this acid-base balance. Let's talk about the role of the lungs first. So if carbon dioxide builds up in hypoventilation, then the reaction will shift right. This will increase protons and lower pH. This is called the respiratory acidosis. If carbon dioxide is blown off in hyperventilation, then your reaction will shift left. This will decrease protons and raise your pH. This is called respiratory alkalosis. You can also think about this in the reverse manner. If your blood pH is low, this means you have more protons, which means you will produce more carbon dioxide, and therefore respiration will increase. But if you have a higher pH, then your respiration will decrease. Moving on to the role of the kidneys. So what the kidneys do is they help by reabsorbing or excreting bicarbonate ions, and they also excrete hydrogen ions in urine. This is slower than respiratory compensation, but it is much more precise. And metabolic acidosis is low bicarbonate, which is low pH. Metabolic alkalosis is high bicarbonate, which is high pH. This makes sense because protons and bicarbonate are on the same side. So you can either have more protons and less bicarbonate, which would be a low pH, or you could have less protons and more bicarbonate, which would be a high pH. And this is kind of how the body regulates pH and buffers pH using bicarbonate. Just to finish off with some clinical tie-ins, diabetic ketoacidosis is actually the same as metabolic acidosis, and this is low bicarbonate, a low pH, and this is where the patient breathes rapidly to blow off carbon dioxide. And vomiting is the loss of stomach acid, and this is also metabolic alkalosis. And just to do a quick recap here, The bicarbonate buffer system maintains blood pH using a reversible reaction between carbon dioxide and bicarbonate. Carbon dioxide acts like an acid and is regulated by the lungs. Bicarbonate acts as a base and is regulated by the kidneys. The Henderson-Hasselbalch equation explains this relationship. The lungs give you a fast response, and the kidneys give you a slower but more powerful response. That's it for today. In the next episode, we'll talk about blood vessels.